All right, so here's your properties of logarithms today, you guys, that we'll talk about. And I just want to remind you, we talked about last time, like here's y equals 2 to the x, and its inverse, if we flip-flop x and y, its inverse we called log base 2 of x, right? All those points flip-flopped. And they were reflected about that line y equals x, right? And so they're inverses, and so they undo each other. So in other words, if we take their composition, so if I take 2 to the log base 2 of x, it'll undo it. And it'll just leave you with that x right there. And same thing if we take the logarithm. If I take log base 2 of, and then I put the exponential in, 2 to the x, it'll undo it and leave me with x. Okay, so that's these two properties right there. Okay, and of course log base b of 1 is 0, right? It's going through that point right there, like log base 2 of 1 is 0. Right, so log base 3 of 1 is also 0. Log base b of b, log base b of b to the 1 is just going to be 1. It's like log base 4 of 4 to the 1. They undo each other. It just leaves you with 1, right? And then these 5, 6, and 7 are unique to logarithms right here. 5, 6, and 7. So number 5 is called the power rule. And so that r right there can be put in front. So it's the same as r log base b of m. Again, these are unique to logarithms. The next one's called the product rule. And the last one's called the quotient rule. So log base b of m over m, n, is the same as log base b of m minus log base b of n. So we're going to use these to simplify these expressions here. So I've got here, notice I have log base 3 of the 9th root of 3. So I'm going to write that as 3 to the 1/9. Well, I know, here's log base 3 of x, and here's 3 to the x. Well, I put them together, they're going to undo each other. Log base 3 of 3 to the 1/9, they're just going to undo each other and leave you with 1/9. Right, that's the rule. Log base 3 of 3 to the 1/9, 1/9. E and the natural log. Well, if you think about, here's e to the x, 2.718 to the x. Here's e to the x. Its inverse is log base e of x. Well, that was a special one. We called that the natural log. So they also undo each other. So when you do their composition, e to the ln of whatever, they'll undo each other. It'll leave you with that whatever. E to the ln of 6 is just going to be 6. They undo each other because they're inverses, right? It's one of those properties. Let's keep going with this one. So this one, what I'm going to do is I'm actually going to take this inside for a minute. Let me just work with the inside. This log base a half of 1/4. Now, if you think about 1/4, isn't that the same as 1/2 squared? So log base a half of a half to the 2 is just 2, right? Log base a half to the 2 will just be 2. They'll undo each other, right? They're inverses again. So what I have is, I have 2 for that. So now what we're solving is log base 2 of 2. Well, what's log base 2 of 2? Let me write it this way. Log base 2 of 2 to the 1 is just 1. Yeah. Now this one, what I'm going to have to do is look at this exponent here, this log base 5 of 6 plus log base 5 of 7. I'm going to actually use the product property, which is this one up here. I'm going to go from here to there. So I'm going to condense it. So this is the same as log base 5 of 6 times 7. In other words, log base 5 of 42. Okay? So that's That's that exponent. So now let me write this. This is 5 to the log base 5 of 42. Well, remember, they undo each other. 5 to the x and log base 5 are inverses. So 5 to the log base 5 of 42 is just 42. It's just going to undo each other. Leave you at that 42. Now what we're going to do here is we're going to go ahead and expand the singular logarithmic expression here. So right now it's log base 9 of x squared times square root of 3x minus 5. So I'm going to use the product property and expand it. So I can go plus. So this is true for logarithms. Okay, because I got to see how I have that multiplied between them. So I can split those up into two separate logarithmic expressions. And now what I'm going to do, here, let me write this as 3x minus 5 to the 1/2. Now I'm going to use the power rule, so I can put that 1/2 in front and I can put that 2 in front. So this becomes 2 log base 9 of x plus 1/2 log base 9 of 3x minus 5. Okay, and that right there is an expansion of the original single term. We've taken that first term, we expanded it, and we've written it as a sum or difference of logarithms. This next one here, we have the natural log of x plus 5 to the 4th. Remember, the natural log is the same as log base e of x. So those same properties hold. So the property was, it said log base a of m over n is the same as log base a of m minus log base a of n. Right? That's the quotient property. This is just log base e, or the natural log. So I'm going to write this as the natural log of the top minus the natural log of the bottom. And now I'm going to use the power rule. I'm going to put that 4 in front, and I'm going to put that 3 in front. So I have 4 natural log x plus 5 minus 3 natural log of x. And we just expanded that one. They do kind of get to be a bit of a mess here. What I'm going to do here is I'm going to use a quotient property first. So I'm going to take log base 5 of the numerator, x minus 5 to the 5th, times x minus 2 to the 1/3, minus log base 4 of that x minus 1 to the 4th. And now what I'm going to do with this is I'm going to use a product property to expand that. So that'll become log base 5 of the first one plus log base 5 of that next one. And then we've still got this minus log base 4. Oh, I'm sorry. I don't know how this became 4. This is supposed to be... sorry, guys. These 5s are supposed to be 4s. This is all log base 4. And now what I'm going to do is I'm going to use the power property, so I can put that in front right there. So I got 5 log base 4 of x minus 5 plus 1/3 log base 4 of x minus 2 minus 4 log base 4 of x minus 1. Well, one more. Now notice this one is all natural log of a bunch of junk to the 1/4. So I'm going to put that 1/4 in front first before I even start this. Now I'm going to expand that with the quotient property. So I'll have a 4th. Now I'm expanding the natural log into 2 terms. So I got to make sure I leave this in brackets. Natural log of the top minus the natural log of the bottom. And now notice I have a minus here. So I'm going to use a quotient. Or I'm sorry, I already used the quotient property. My goodness, what am I doing? I'm going to go ahead and factor this because I know this is x minus 2, x minus 3, minus, and I'm going to go ahead and use the power property there. And then I can expand this one, right, with a product property. So I have a fourth. You expand this ln x minus 2 plus the ln x minus 3 minus 2 ln x plus 2. And then finally, I can go ahead and distribute the fourth through to everybody. So I have 1/4 natural log x minus 2 plus a fourth natural log x minus 3 minus 2/4, or minus a half, natural log x plus 2. And you know what? I just realized I don't know how that 3 ended up being a 2. That's a 3 right there. I'm sorry. That's a 3. So that's 3/4. 3 times 4. That's 3/4. Good grief. Making a mess of this thing. There you go. All right, let's keep going here. We got log base 5 of 2x to the 4th. Again, we're going to write this as a sum or difference. It's our last one that we're going to expand. And then we'll start going the other way around. We'll start condensing them. Okay. Let's go ahead and write this as 2x to the 4th, x minus 4. Notice I had a minus, right? Minus the bottom. And then with this one, notice these are being multiplied. Whoops. So I can expand this one, log base 5 of 2x to the 4th plus log base 5 of x minus 4. And then over here, I also got a multiplication issue, I got the product property. But make sure as you expand this, you put these in parentheses. Right, that negative will apply to both terms there. Okay, so what we have is, and I can do product property one more time on this. I got log base 5 of 2 plus log base 5 of x to the 4th plus log base 5 of x minus 4 minus log base 5 of 5 minus log base 5 of x minus 3 to the 5th. Okay. Now notice that 4, that can go in front, that can go in front. And then notice this log base 5 of 5. Well, log base 5 of 5 to the 1 is just 1. So this is minus 1 right there. So I got log base 5 of 2 plus 4 log base 5 of x plus log base 5 of x minus 4 minus 1 minus 5 log base 5 of x minus 3. And that's it. We just expanded that. Okay. So now we're going to go the other way around. So now we'll go the other way around. We're going to condense it. We're going to write it as a single logarithm. So that 1/2 is going to go up. This 2 is going to go up. So we'll have log base 6 of x to the 1/2 plus log base 6 of x minus 2 squared. In other words, let me write it this way. That's square root of x. And now notice I have a plus between them. So I can use that product property and write square root of x times x minus 2 squared. So log base 6 of root x times x minus 2 squared. We just condensed it now. So we're going the other way, right? We're taking multiple terms and writing them as one single term. We're condensing the logarithmic expression. We're going to do the same thing here. I'm going to take that 2 up. So I have ln of x squared minus 1 minus the ln of x plus 1 squared. Notice I have a minus between them. So this will be the quotient rule. I'll have x squared minus 1 over x plus 1 squared. Now be careful on this. Notice the top will actually factor into x minus 1, x plus 1, and the bottom is x plus 1, x plus 1. So notice those cancel. So you're actually left with, on this one, x minus 1 over x plus 1 is actually where you end up with this one. There's your single logarithm, again, that we condensed, right? Let's keep going with this next one here. Let's take that negative 2 up, right? Take that 3 up. Let's see what we got here. We got log base 3 of x to the negative 2 plus log base 3 x squared plus 2 minus log base 3 of 4 plus log base 3 of x to the third plus log base 3 of 8. Now these ones have a plus, so I'm going to write as multiplying. I have x to the negative 2. That's 1 over x squared times x squared plus 2 minus log base 3 of 4. I'm going to go ahead and multiply those two as well. So I got log base 3 of x cubed times 8, or 8x cubed. So what we have here is log base 3 of x squared plus 2 over x squared minus log base 3 of 4 plus log base 3 of 8x cubed. Now notice these are a minus. So I'm going to have log base 3 of x squared plus 2 over x squared all over 4. Well, that's 4 over 1, so I got to simplify that, multiply by 1/4. So what I have is log base 3 of x squared plus 2 over 4x squared plus log base 3 of 8x cubed. And now I got a plus, so I can multiply these. So I have log base 3 of x squared plus 2 over 4x squared times 8x cubed. Well, if you notice, 8x cubed divided by 4x squared will give you 2x. So what we're left with is log base 3 of that 2x times x squared plus 2. You could leave it right there, or you could distribute that 2x through as well. It doesn't matter on that. And that's condensing these logarithmic expressions. The last part of this section is getting into change of base formulas. And if you remember, in the last section we said our basic calculators can only do basic common logarithm. They can take like log of 7 or like log of 9, whatever, but it's log base 10. That's the log button on our scientific calculator. And then the other one it can do is log base e, which is known as the natural log, right? We use the natural log key. So with a basic cheapy scientific calculator, you're not able to do things like log base 5 of 8 because it's not a base 10, it's not a base e, it's not the natural log, and it's not the common log, right? So what you can do is you can use this change of base formula and just change its base. So let's change it to base 10. So according to the formula, I could go, this is the log of 8 over the log of 5. In other words, log base 10 of 8 over log base 10 of 5. And then we could just punch it in to our calculator. So we pull up Desmos. Let's go ahead and pull up Desmos and punch in log of 8 divided by log of 5. So I'm going to go to, let's see, function log of 8 divided by log of 5. And look how we get 1.292. Okay, 1.292. Let me go back. So approximately 1.29 if we're going to round it to 2 decimal places. Well, that's not the only one we could change the base to. We could also write this, we could change it to log base e. You can change it to whatever base you want. Whoops, that's supposed to be 8. Log base e of 8 over log base e of 5. In other words, the natural log of 8, natural log of 5. So you could use the ln key, and you'd see you'd also get the 1.29 if you punch that in. All right, so this change of base formula is really nice when you're punching those in to your calculator, right? For any old base, you can change the base. Here's where it could play into simplifying as well. Notice that if I change the base on this to base 10, so I'd have log of 8 over log of 3. Again, that's base 10. Change this to base 10, so that's log of 9 over log of 8. Notice our log of 8's cancel, so I'm left with log of 9 over log of 3. Let me write this a different way. That's log of 3 squared over log of 3. Well, the 2 can come in front, right? So it's 2 log of 3 over log of 3. And now the log 3's cancel. This is just, you're just left with 2. So log base 3 of 8 times log base 8 of 9 is actually just 2. Right? So that's kind of some useful information there. Is you can actually change your bases, right, with that change of base formula. Well, thanks so much for watching. We'll see you guys next time.